All right, guys. So for the first one, is that one discrete or continuous? Yep, discrete. And then B? Continuous. So remember, discrete is when you just have points, and then continuous is when they're connected with a line. Okay? Yes. Continuous. Because it's like not just jumping, like it's like continuously flowing. Yeah. Mm-hmm. All right. Make a list of as many points as you can for each of the graphs above. So for A, anyone have a point? 1, 3.
4, 2.
1, 3. What was it? 4, 2. 6, 6, and 2, 1. Okay, what else? Okay.
-1.
Yep. Okay, for B, what do we think? -2 what?
-2.
-2, -2. Yep, that works.
-1, 2.
-1, 2. Yep. 0, 0. 1, -2. And 2, 2. Any more? So remember, points don't have to be whole numbers. Yep, that's it. That's exactly the point I'm trying to make. So B is going to have an infinite amount of points because this entire line is covered with points at every single point. All the fractions, all the decimals, everything. So there's an infinite number of points on that line. So if I asked you to list all of them out, it would be impossible, right? Yeah. So kind of keep that in mind as we're going through this today. So we're doing domain and range. Your objective is students will be able to find domain and range of discrete and continuous functions. It should be the same packet that you were on before. Yeah. All right, so domain and range. So domain is going to be the list of input or x values. Range is going to be your output or y values. They're written from least to greatest, both of them. So for domain, that would be left to right. So domain is going to be written left to right. Range is going to be written from bottom to top for least to greatest. And then also we don't repeat. So smallest to biggest and then no repeats. So if something's listed twice, you only write it once. Okay, so for problem 1, if I'm doing domain and range, so domain is going to be all of your x values. So I'm going to look at -2, 0, 4, and 5. And you're going to write those least to greatest, no repeats. They're already like that. So just -2, 0, 4, 5. And then your range, you're going to look at all of your y values. So I have 0.5, 2.5, 6.5, 2.5. So we're just gonna not repeat the 2.5. So I'll just have 0.5, 2.5, 6.5. All right, so for B, I have 6, 4, 6, 5. So how would I write that least to greatest with no repeats? Yeah, 4, 5, 6. And then range, I have 5, 3, 4, 8. So how do I write that? Yeah, 3, 4, 5, 8. Okay, and then go ahead and do the got it. Exactly. The y values, yep. Yeah, so we just if the number appears more than once, we don't repeat it. The 2.5 was twice, so we just don't learn it. All right, on A, domain, we have 4.2, 5, 7, 4.2. So how do I write that? 4.2, 5, 7. Yep. And then range, I have 1.5, 2.2, 4.80. So how do I write that? Yep. Right, B, domain, -1, -2, 4, 7. So you'll have -2, -1, 4, 7. Yeah. Yep. Yeah. And then 1, 2, -4, -7. So you'll do -7, -4, 1, 2. Make sense? Okay. All right, so now we're going to do it where we have a function rule or an equation, and they're going to give us a domain, and we're going to find the matching range, okay? So for problem 2, the domain of y equals -1.5x plus 4 is 1, 2, 3, 4. What is the range? So we're going to take our equation, y equals -1.5x plus 4. These are the domains, so it's going to be the x values, 1, 2, 3, 4. We're going to plug them in for x in the function and get the matching y values and then write out the domain, okay? So we're going to do -1.5 times 1 plus 4, -1.5 times 2 plus 4, and so on. So grab a calculator. Also, guys, we're missing a calculator, so I think somebody accidentally took one home. I don't think anybody did it on purpose because it would be dumb to steal those because the yellow ones are always school property ones, so everyone would know. But can you guys check your even if you don't think that you did, can you just check your backpacks and check at home and just try to track it down for me because that makes me nervous. Okay, what do we get when you plug in 1? What is it? 2.5. Okay, and then 2. 1. Okay, 3. I think you just wrote the negative in front of the. Okay. Yeah, negative 0.5, and then. Negative 2, right? Negative 2? Okay, so then when you're listing out your range, you just want to put it in order and all that. So what order am I going to write that in? Negative 2? Mm-hmm. Yep. Correct. Make sense? Go ahead and do the next one. So it gives you the x values to use. So this one, it's y equals 4x minus 12. And the domain they gave you is 1357. So you do 4 times 1 minus 12. And what do you guys get for that? 8. And then 4 times 3 minus 12 is what? 0. Then 4 times 5 minus 12. And then 4 times 7 minus 12. And then to write your range out, that would do what? Yep, negative 8, 0, 8, 16. Yep. Any questions?
Wouldn't it be 0 for 4 times 3 minus 12?
Yes.
Oh, you wrote 1. Oh, no, you didn't.
No. All right, good so far? Yeah. Okay. So now we're going to talk about how to do this for continuous versus discrete. So if you kind of look back at the warm-up right here, that's kind of what we were doing here by listing these points out. It was kind of like that same idea. So if it's discrete, it's going to be a lot easier to actually list out all the x and y values that we have. If it's continuous, it's going to be impossible because we have an infinite amount of them, right? So for continuous, we're going to have to write it a little bit of a different way. So here, so continuous, the way that we're going to write those, they're going to be written as inequalities or interval notation like this. So all you're doing is finding the smallest one and the biggest one, like the endpoints, and then it's going to include everything in between, okay? So this one, this would be an inequality, if you wanted to write it like that, and then this would be interval notation. I need you to know both, okay? And then for discrete, when it's just the points, we can write those as just a list of values. So just listing out all the numbers. All right, and then once you have the domain, because typically in this situation, like the scenario they give you, you're only going to really be able to know the domain. Then you're just going to plug in whatever you have to find the range. So either you'll plug in just the two endpoints, or you'll plug in every single value. Okay, it just depends. So you're going to be given a lot of information for these problems, and you have to kind of isolate like what's going to be the information you actually need for the equation, because you're not going to use all of it, because the other information is going to hint at like what your x and y values could be. Okay, so for the first one, your percentage on a 4-question quiz of each question is worth 25 points. So let's write an equation first. This would be y equals what? Yep, 25x. So we didn't use all the information they gave us. We didn't use all the numbers. But for the equation, since each question's worth 25 points, it'd be 25x, 25 points times the number of questions you get right. Okay? So in this case, x would stand for what? Yep, so x would be the number of questions correct. And then y would stand for what? Yep. And then do we think this would be discrete or continuous? Discrete, yep. Because we're going to have a very specific set of values that we can use for number of questions correct. We can't just use anything from this to this. So for domain, x is the number of questions correct. So you're listing out all the possibilities for a number of questions correct. So what's the lowest amount of questions I could get correct? 0. Then what? Then, yep. So that's where the 4-question quiz, that's where you're using that. Just knowing how many the max is. Okay? So then for the range, you're now listing out all of the matching percentages for those situations. Okay? So if I get 0 questions correct, what would my percentage be? 1, 25, 2, then, and then, yep. So that's discrete, where you're just listing out every possible value. Okay? All right. The amount you make working, if you make $10 per hour, start at 5 p.m. and can stay no later than 10 p.m. but can leave early if you want. Assume you actually go to work. So what would my equation be? Y equals what? 10x, yep, because $10 per hour. And what's x going to stand for? Number of hours, yep, so number of hours you work. And then what's y going to be? Yep. How much money you make? Well, that's if you work 1 hour. Right? So, let's think. It says we start at 5 p.m. and we the latest we can say is 10 p.m. Is it possible for me to sit here and list out every single option for how much time I could go to work? Down to the second?
Yes.
I gotta say 1 second, 2 seconds, 3 seconds, all the way to 5 hours.
A lot of paper.
And then milliseconds.
A lot of patience.
And then, so that's gonna, I ain't doing that, okay? So this one's gonna be continuous.
But it's possible.
It's really not. You can get infinitely smaller of how you measure time.
But eventually you gotta hit rock bottom.
Nope.
Not really?
That's what infinity is. That's the idea of infinity. Think about if I were to walk to that wall, but I was only allowed to go half the distance every single time, would I ever reach the wall? No, because I'm only ever allowed to go half the distance. Yeah, mind blown. Yeah, no head. Yikes. All right. So the way that we handle this, because it's an infinite number of options, is we just do the lowest and the highest, okay? So for domain, and I'm going to write it in both inequality form and interval notation form, okay? So what is the lowest amount of time that I could work? 0, kind of, right? What's the most amount of time I could work? 5 hours. So here's how we're going to handle the 0, because it says assume you actually go to work. So I can't equal 0, but I need a way to say 0 but not 0. So how do I say that? Huh? But I have to go to work. So I need to find a way to say the lowest amount that would be 0 but without being 0. Exactly. So we're just going to basically not make it equal to in our inequality. Okay? And then since I could work 5 hours, like I could equal like the full 5 hours, you're going to put the equal to on that. So the way that translates over to interval notation is a parenthesis on the 0 and then a bracket on the 5.
Okay, so trying to do that equation breaks calculator. Got it.
Huh. Yeah. I think about it way more than I should. Nope. All right, so here, so this is basically saying I can work anywhere from 0 to 5 hours, but I can't actually work 0 hours. I have to work something above 0, okay? Then for the y's, it's going to be the possible amounts of money that you could make. So if I use an inequality, I'm going to use y in the middle this time. So what's the lowest amount of money I could make if 0 hours? $0. 5 hours? $50. And same thing, it's just you're not going to actually equal $0, but you could equal $50. So then it would look like this: 0, 50. This is like new, so like if your brain is like protesting a little bit, that's normal. Okay. Any questions on that? So do we understand why I had to do these differently? This one, I knew all of the possibilities. This one, it's impossible to list all the possibilities, right? So you just do smallest to biggest. Okay? All right, you guys try these ones. So I will tell you one of them is discrete, one of them is continuous. Start by maybe figuring out which one is which, okay? And that'll kind of, and then just write the equation and just take it like step by step. So guys, figure out what information they're giving you that's going to point towards an equation, and what information is going to just be like the possible x and y values. Like another minute or so. All right, so the first one is the amount of time you spend reading if the book is 300 pages long and it takes you 3 minutes to read a page. The second one is the amount of money you make selling candy bars if each bar costs $2 and you only have 10 bars. Which one is going to be discrete? The second one, yep, because it's the whole candy bars you're selling. And then this one would be continuous because it's like, just think about like the actually reading. So you're reading, you're not like only reading full pages at a time, you're reading partial pages also. So anything in between, okay? So for the first one, what would my equation be? Y equals what? Yep, 3x, because it's 3 minutes per page. And x is going to stand for what? Yep, number of pages. And y is going to stand for what? Huh? Yep, number of minutes. Yep. So since this is continuous, we can't list out all of the options of like how many pages, because it's like you can do partial pages too, like you could stop halfway down a page. So smallest and biggest. So domain for number of pages, what's the lowest amount of pages? 0. And the highest? And then equal to or not equal to both one of them. Does it specify that you have to start reading the book? No, so they could equal 0. You could just decide I'm not reading it. Could it equal 300? Yeah, no. Could I read all 300 pages? Yeah. So it's going to equal to both. So if you did it as an inequality, it'd be like this. So the number of pages is going to be between 0 and 300. Is basically what that says. And then range is going to be the number of minutes that correspond to those. So what's the smallest amount of minutes I could read? 0 to what? 900. Yeah. Because it's 3 minutes per page. And make sure you change that to y whenever you do range. Okay, any questions on that one? All right, so this one, the amount of money you make selling candy bars if each bar costs $2 and you only have 10 bars, y equals what? 2x, yep, because it's $2 per bar. And x is going to stand for what? Yeah, number of bars. And y is going to be what? Money. Okay, so for this one, we have to actually list out the values because we can't have the in-betweens, right? It's only specific numbers. So what's the lowest amount of candy bars? 0. So 0, 1, 2. Where do I stop? So that's all the possible number of candy bars I could sell. Yeah. And then we're going to list out all of the possible amounts of money that I could make. So what's the lowest amount of money? 0. Yeah. And then what? It goes in multiples of how? What?
10 to.
By 2. Yeah. So it's going to go. So it's be $2, $4. So up to $20. Okay. Any questions on that? Okay, so for all of that for a minute, I think people put it to copy. So just get like a minute. Okay. All right, let's move on. So now we're going to do this on graphs, okay? So the first step of this process is deciding whether or not your graph is discrete or continuous. So do you remember how to do that? What's the first one? Continuous, yep. B? C? Yep, so it's whether or not it has a line or not. So think back to the warm-up that we did. So when we had to list out the points for the warm-up, for the discrete one, we could list out the points. For the continuous, it would be an infinite number of points, so we can't. Okay, so they're going to be written the same way as the ones that we just did, with the continuous being kind of like an inequality or interval notation. So for domain, for continuous, you are going to, so domain, you're working from left to right, and you're looking at the x-axis. So you're finding whatever point of your line is all the way furthest to the left, and then following it up to the x-axis or down to the x-axis to see what value that's at. So all the way to the left here is this point, right? So what x value is this on? -4, yep. -4. And then this is an open dot. So that means not equal to. So you're going to use a parenthesis on that one. And then all the way to the right would be over here, right? But this is an arrow. So that's going to keep going. It's not going to stop there. So what would I use? Infinity, yep. And then infinity always gets what? Parenthesis. Or you could do this. So those are your two options. For range, you're going to kind of do the same thing, but instead of focusing in from left to right and then looking at the x-axis, you're focusing in from bottom to top and looking at the y-axis, okay? So the lowest point is still the same point, but followed over to the y values. So what y value is that at? Yep. -1, and it's an open dot still, so it's me parentheses. And the highest point up here is still your arrow. So what do I put? Infinity, yep. Or you could write it as this. Make sure you put y in the middle for the range. Okay, any questions on that? So furthest left, furthest right, and then bottom top. Okay? So for discrete, for the graph, for domain, you can literally list out all the values you need to, okay? So start furthest left, and you're focusing in on just the x-axis. So this point right here, what x values is that? -2. And this one's at what x-axis? What x? -1. And these 2 points are at what one? 1, yeah. I thought it was hard to see. And these two are at what? 3, yep. And then you're going to do the same thing, but you're going to do bottom to top, and you're going to be following it over to the y-axis, okay? So what's the y value of these 2 points? Yep, -2. The y value of these 2 points? Oh, no, wait. Those are just my marker lines. Just kidding. So this point would be next right here. What would that be at? 0. And then these 2 points? 1. And then this one? 3. Mm-hmm. Make sense? Okay. Okay, then the next one's continuous again. So remember, for a domain, you go left to right, and you're looking at the x-axis. So furthest left is going to be this point right here. And that's at what x? Yep, -4. And it's an open dot, so I do use parentheses or brackets. Parentheses. Yep. And all the way to the right is this point right here. What x is that at? 3. And that one is a closed dot, so what would I use? Bracket, yeah. Or you could write it like this. Okay, and then for the range, bottom to top. So the lowest point is still this one, this open dot, but what y value is that at? -5, yeah. And then parentheses, because it can't be equal to, it's an open dot. And then the highest one is right here, at what value? 2. And then if it's your line that is touching that value, I'll treat it like a closed dot, okay? So that one I'll get a bracket. Or you could do -5 y 2, like that. Any questions? No? All right, go ahead and try the next ones. Mhm. Mhm. On this one, this,
Yeah.
that's narrow.
Oh, I Okay, take like 1 more minute. I need you to know both forms, but you can just write one. Yeah, it just depends on like what Math Excel. I'm not sure what Math Excel is gonna ask for the problems, like which form. All right, guys, let's go over this. So for this one, hold on, we're done at 24. Thanks, okay. That's fine. We just need to finish this one. These are just extras. All right, domain. So this is continuous, right? So if I go all the way to the left, what x value is this at? -4, and that was a closed dot, so parentheses or brackets. Bracket. And all the way to the right, I have an arrow, so what do I use? infinity with a what? Parentheses, yep. Or you could do, that's your other option. Okay. All right, and then range. Remember, bottom to top. So all the way to the bottom is this point still, right? But you're looking at the y value. So what y value is that at? Yep, so it's right at 0 for the y. And then the highest point is still an arrow, so infinity. Or you could do this. Because that's the y value. Does that make sense? So this point's at -4, 0, because a -4 you'd use for the domain and a 0 you'd use for the range. That's where I always make mistakes too, is like doing the wrong value. All right, this one is discrete. So for the domain, we're gonna list them all out. So left to right. So this one's at what? -2. This one's at what? -1. This one's at 0. This one, 1, and this one, 2. And then range bottom to top going across. So these two are at what? 0. These two are at 2, and this one's at 3. And this last one's continuous. So for domain, left to right, so all the way to the left is this open dot at what x value? -5, and since it's an open dot, parentheses or brackets? Parentheses. And all the way to the right, we have this point, which is at what x value? -2, parentheses, yep. So you could have this also. And range is bottom to top. So lowest is this point at what y value? 4. And this is the highest at 4. Yeah. Okay, good? Yeah? Okay, so these ones were just like Math Excel, like review ones in case we had extra time. So we don't have to do those. I'm gonna put up the lesson check in case you want it. Okay, so number 1, oh, yikes, just kidding. We're not doing that. There's like a graph and everything you have to look at. Yeah, we're just gonna skip it. Okay, so we'll just skip the rest of that. So you have at least all the notes and stuff that you need. Okay.